All right, good morning. And let's now go over some important items reminder very quickly. Okay, again, as I said on Monday, Lab 1 has been released. I think you still got the scheduled lab session next Tuesday. We can make some time. I think I got some important things scheduled for next Tuesday. I'll talk about it. So, but you can still ask me questions about Lab 1. Either next week, Tuesday, but might be too late, but drop by my office hour if you need any help. Lab 0 Part 2, you should be finishing that soon, and that one is due on Friday, 2 p.m., all right? Not midnight, 2 p.m. Written test number 1, that'll be your first assessment for the course. That one there, I'm gonna release a precise guide about what you can expect. So roughly speaking, you have to show up in the beginning of your scheduled lab session, which will be 4 p.m. on Tuesday in the Williams Small Center. You will need to wait outside before me and TA set up the room, and then we'll let you in. So don't worry, we'll start in time. So that one there, let me just mention, it's gonna be in the Williams Small Center. I'll give you the precise roll number, actually, that you have to go. And then, these are the two things I already mentioned yesterday. You want to make sure you can do it. Oh, sorry, just one over here. You want to make sure you can log in to the Williams Small Center computer, and also you can access the e-class. You will need that for the written test. If you haven't done that yet, I would suggest try to drop by Williams Small Center yourself. Just make sure you can do it. For example, if during the written test in the beginning you cannot really log in for whatever reason, if that's the problem is really on your side, we cannot really accommodate. So please make sure you can do that. All right. And I'm gonna release a guide and also some practice question about your written test number 1. I hope to do that by the end of today. If no, definitely by the end of tomorrow. So you can start preparing. But you should really start studying for your written test 1 by studying the lecture. All right. And for your programming test 1, that's gonna happen 1 week later after the written test 1. I will give you precise guidance about how you should really get prepared in the format. It's gonna be in person again. All right, it's going to be also in your Williams Small Center. But the format will be a little bit different. Okay, what I can say now, it's going to have the identical format as Lab 1. You will be given JUnit test cases, and you have to program from scratch in the empty model package for whatever that's needed. Right, that's number 1. And if you're kind of worried that, whoa, Lab 1 is so long, am I going to program something like a Lab 1 within the test time? No. I will give you something that's reasonable to complete. You will get about between 6 to 65 minutes. I haven't confirmed just yet, but I will. Between 60 and 65 minutes, you will have to complete whatever you're given. But it's definitely going to be shorter than Lab 1. And I'll give you some guidance, some practice tests you can definitely try at home. And there will be something optional for you. I think I'm going to confirm, most likely this is going to happen. So next week, next Tuesday, in your scheduled lab session, after you finish the written test, you can choose to stay to actually take some mock-up test, which will not be graded. It's only for you to get familiar with the working environments if you want to. It wouldn't be long. I think just for you to get a feel. Maybe I can schedule the test to be 30 minutes. I can give you something very simple just to try. You can try to import the projects, try to do something, and try to run the JUnit test cases, and then export the project and submit. That's something you can practice. Right? I'll give you more information, but just have some idea. These are coming. Do you guys have any questions related to administrative issues before I talk about stuff, the contents? Alrighty. Right, so my plan today, I want to talk about 3 more things about the review. Number 1, we're going to talk about the more advanced use of this keyword. We're going to do some exercise together. Number 2, I want to briefly mention about the helper methods. I will just go over one slide to give you some concepts, some idea, but you will have to go over the code that's actually on the slides. They are pretty straightforward to follow. I also will give you the source code for you to play with. Number 3 will be the static variables. We're going to talk about them. All right, so these are the 3 topics. And then whatever time that will remain, hopefully we'll have some time, we can move on to the new topic about exceptions. So that'll be the plan. All right? Let's now go on to the first topic, which is about the use of this keyword. Okay, let's consider the following exercise. Right? Let's now consider this person class over here. Right? You can see the person class. We got attribute name. We got another attribute spouse. Remember we said before, the attribute can be reference type. In this case, just another person. Right? And of course, the spouse may be null, may not be null. Depends. And we have the person constructor over here, which will just initialize the name, right? Everything is good up to now. And here is our task for programming. How do we implement a mutator method inside this class, which means it does not return anything, it will only modify the attributes. In this case, it's going to modify spouse somehow. So we want to have a method called marry, which will marry the current context object person to another person. Basically, that's what we want to do, all right? How do we implement such a mutator, all right? I want you guys to kind of think about how you may do this, but I'll give you some hints over here. That's something I can give to you to start with, and then I'll pause for a minute so you can think about. So that's the person class I just went through with you, right? This will be the marry method. Number one, it is a mutator, right? Does not return anything. And it takes its parameter another person, like other, right? So that means inside the body of implementation, you're somehow going to refer to maybe any of the attributes and also any of the parameter. That's what you're going to do. And I would suggest, let's say you're given certain method to really program. You don't necessarily have to start coding right away. Try to make up some example yourself to think about how the method is going to be used. That would be a very good way to give you some inspiration. For example, let's say, so this will be some example code we're going to use just for design, the method here. And later on, we're going to use this method, this fragment to also trace the code. Let's say we got two persons here. We got Jim, and also we got Elsa, okay? The way we're going to use the method here, right? You can see it belongs to a person class. So that means the context object must be a person. Jim is a person, not a problem. So we can say Jim.marry another person. So this another person will be just Elsa. That's how we use it. Okay? But now you want to think about, in order for me to implement this method correctly, two things to consider. Number one, if the marriage is allowed, what should be the consequence of marrying Jim to Elsa? Number two, what if the marriage should not be allowed in the first place? For example, well, normally, right, both of them should be single. And number two, maybe Jim should not marry to himself, right? So these are kind of the conditions you want to make sure they actually are not really met before you can marry two persons, right? So there are two things. You want to think about two things over here. Number one, normal scenario. And number two will be abnormal scenario. Normal scenario will be you would just simply marry the two person. Okay? Abnormal means, for example, cannot marry one to themselves. Number two, can't marry someone who's not single. Right? If somebody is already married, presumably you cannot marry them. Right? Right, these are the two kind of cases you want to make sure they're both covered in the method. Well, if we talk about cases, what do we have to use? Loop, if statement, yes, very good, thank you. All right, guys, I'll give you like 1 minute or so to think about how you may actually code this up. I can tell you that the abnormal case is easier to specify as a Boolean condition for the if. The else part, which will be the normal one, how you actually can marry, let's say, Jim to Elsa. You want to make sure, okay, put it this way. After marrying Jim to Elsa, that means Elsa will become Jim's spouse. Symmetrically, Jim will also become Elsa's spouse, right? It's bidirectional. You want to make sure you got two variable assignment to cover that, right? If you kind of understand what I'm trying to say here, now the rest will be to translate it into Java. That's something we have to do. Okay, so this part here is just about a conceptual sketch you have to remember, and then we're gonna reveal the code very soon. Okay, I will pause for one more moment, and then I can maybe take some idea, if you guys have any idea. All right, why don't we start with the abnormal case? Something like this. I'll write the code here. We're going to say if some condition over here is actually true, that will be the error condition. In this case, we're going to do some error, right? I'll just sketch, just error. Either you can print some error message to the console, which will turn out is not, actually not a very good practice. It's better to use exceptions, which we'll cover later. But just say error. This will be the error branch. Otherwise, it's going to be the normal branch, in which case we're going to marry the two persons together, right? Why don't we figure this out first? How can we translate number 1 and number 2 into this block? Yes? What if there are, let's say, 2 Jims, but they're different persons? So I would say, yeah, so my point is checking just the name itself may not be good enough because you cannot really guarantee that the attribute values for 2 objects are the same, which is okay. So I'll give you a hint. It's always safe to assume if 2 objects are different, their addresses must be different. So how would you compare their addresses? Well, let's say the example there. In the example over here, this one here, right? We want to make sure, number 1, how do we make sure Jim and Elsa are different persons? You would say their addresses are different, right? How would you write it? You would say Jim not equal to, right? Elsa. Agree? Right? That's what we said before, right? That's how you compare addresses. But this is only at the example level. You want to generalize it into some class definition. How do we do that? Thinking this way, you can see here, Jim is the context objects. Elsa over here is the arguments. When you are trying to program the marry method over here, right? So this is where you're using the method. This is where you are defining the method. How can you somehow generalize this particular usage into the definition over here? That's the question. Can anybody suggest something just for this one here? What should I put in here? It looks like I should do maybe, oh, that's not a good. I should do something like, I certainly cannot say if Jim is not equal to Elsa. This is simply not right. That's not a proper method definition, right? What will be Jim? The context objects. That's something the second one will actually cover, not the first one. First of all, we want to make sure, first of all, Jim is not trying to marry him. So first of all, we want to make sure Jim is not trying to marry to himself. Number 2, we want to make sure if the 2 persons are different persons, they better be single, both of them. That's basically what we want to do. Right? Anyone want to suggest something here? Yes?
Something like if it's not Jim equals Jim, then...
Okay. You're getting somewhere. Okay, let me just write it down over here. Thank you. When you say this dot Jim equals Jim, something like that, right? Okay. I tell you why this would not be correct. Think about if you write this fragment of code in the context over here. Do you actually have Jim declared in this class? You don't. Jim is only created outside the context of this particular class when you're using the method. So in the definition here, you should never mention about the example variables. So that's why it's not right. Okay. I'm looking for. I like the fact that you're using this, but when you say this.Jim, it doesn't make sense. This is referring to the current class like a person. How can we have an attribute called Jim, right? So that's why it's not right. We wouldn't want to use the name attributes actually because 2 different objects may have the same name. So that's why we want to use just the address to tell. Yes. This dot spouse, okay, it sounds a bit, yeah, okay, this sounds a little bit better, okay, but not exactly. You don't want to use dot equals. You don't need to.
This dot person equals other.
This dot person, okay, you mean the equal sign, right? Okay, it's getting closer. Okay, let me just talk about this final answer, and then I should really give you the correct one, right? But guys, I think you should really think about different possibility and know why it's wrong, right? That's why I'm doing this. So what you mentioned before was something like this dot person equals other. I would say it's definitely on the right track. However, again, similar issue. This is referring to person. Do we have another attribute called person? We don't. Right? So that's why this answer is not right. Okay? The correct answer should be, it would be considered as an error if Jim happened to be the same as Elsa. That's an error condition. So that means this equals other. All right? Guys, I think the reasoning process here is very important. I can see you guys might be a little bit struggling, but that's something we should learn. All right? No way around. Okay? Let me just recap very quickly. Think about it. All right? We start with this particular example over here. That's only example. It can only help you generalize what's going to happen. When you want to generalize the definition of a method from usage, you cannot just use the Jim or Elsa example variable. We may have another usage, maybe Jonathan that marry Shirley, for example, right? So then which one should we use? So Jim here is the context objects. So that should be used as this, right? So this part over here should be generalized into this. And Elsa over here should be generalized into the parameter other, which is over here. That's why I'm putting this equals other. Later on, when we trace the code, you will see this will be replaced by Jim. Other will be replaced by Elsa. All right? Number one. All right, so we have covered this one over here. What about the second condition? This will be the first one. The second one, we can go a little bit quicker. It will be following very similar line. Let me use purple. What about the second one? We cannot marry someone who's not single. We want to make sure both Jim and Elsa, they should be single at the same time, right? How do we do that? Yes? Yes, for sure. So how would you write it? You want to read out to me how you will write it? Absolutely. Thank you so much. That's exactly correct. All right. So the second condition here is it would be considered as an error if either Jim is so put it this way. Remember the condition over here should be talking about when error occurs. Yeah, exactly. So let me put it here. Number two would be when the spouse is equal to null. Oh, not equal to null. Beg your pardon. Yeah, so be careful with the logic. Not equal to null over here. Or other dot spouse not equal to null. Okay, let's understand the logic over here. This dot spouse is the person over here. If their spouse is not equal to null, that means they are already married, so we cannot marry them. Or if the parameter Elsa over here or argument Elsa over here, if their spouse is also not equal to null, in that case, they are also married, right? Either way, both of them must be single. All right, that's why it's an or over here. And for 1 and 2, we have to combine them together. Either we got error condition number 1 or we got error condition number 2. If either occurs, we're going to have an error. So that means we're going to combine them using or, right? Okay. So think about this is condition number 1. This is condition number 2, which itself is or. But we're going to combine these together using or. All right, that's the final answer for that condition. Just make sure you really understand it. It's really important. All right? Guys, any question about this? Right? I think it's a very nice example over here to really understand how this and parameter should be used together. Yes. Oh, you're trying to, you're not sure what that really means, right? Okay. I think it might become clearer when I try to trace the code again. How about just hold that for now? If it still is not clear, you can ask me again. Okay. The question was, how do we really understand the first condition there, for example, when we say this equals other? Well, I think things will get clear when we try to trace the code. All right? Okay. What about the else part? Let's say, I'll help you a little bit. Let's say for now, let's say Jim is a person. If we can get to the else part, we are pretty sure. Number one, Jim is not trying to marry himself. Number two, both of them have their spouse being null. They're both single. Let's say Jim is over here, okay? And then let's say person over here. Let me just put the spouse. And we know that it's guaranteed because we are now in the else part. So this will be null. Let's have also Elsa as an example. Elsa over here also got the person here and then spouse. And then null, right? Let's say we are now in the else part. What code should we write to have the following consequence? Diagrammatically, Jim is single, Elsa is single. What does it really mean to marry them? That means Jim, the spouse, should be set to Elsa. Symmetrically, Elsa, the spouse, should be set to Jim. Agree? How do we do that? Let me help you a bit if you're a little bit confused. Let me see. Okay, just the else part, all right? Just the else part over here, okay? We say Jim, the spouse, should be assigned to Elsa. Also, Elsa, the spouse, should be assigned to Jim. That's basically the arrow I just draw, right? Like here and also here. That's what I just draw. However, you cannot put these two lines in the else part because you don't have Jim and Elsa in the context. You want to generalize them, like what we did. Any suggestion here? Please. Okay, I like that. Okay, I heard your first line. Let me put it down first. You said, rather than Jim, I'm going to put this. Am I correct? And what about Elsa? Other? Okay, I agree. What about second line? Well, you know what? You're pretty good in the first line. I can tell you, second line is slightly weird, right? Elsa is easier. Why don't we just replace Elsa by other? Because Elsa is the parameter, right? Okay, let's do that. This part here is going to be other. Jim is going to be just this. Guys, I know the second assignment is really weird, but I can tell you that that one happens very often in OOP, very, very often. That this itself is simply used as the target, that this itself is only used as the right-hand side of the variable assignment, right? Let me try to help you a bit with understanding this, and we'll trace the code. Hopefully things will be better. For both the error condition over here and also for the else part over here, we don't really try to program right away. What we try to think about is using this particular example, concrete example, using Jim and Elsa. It's just easier for you to think about how the object should be changed over here. And then once you put down things, the definition in terms of Jim and Elsa, you have to somehow do the replacement to generalize Jim into this and Elsa into other, right? That's basically what we did. That's the definition. So what I will do now is to do a final step to help maybe Kevin to understand this part over here, right? So the complete solution is actually over here, right? You can see that on the slides. And by the way, actually the version we did in class is even better than the version in the slides, because in the version we just did, we'll even consider this equals other is considered as an error. So you want to learn that as well. I want to trace this code very quickly together with you, okay? Let's say we have already implemented the method, let's say. What we want to do now is to see how these 3 lines of code can be traced, how to use it, okay? Line number 1, easy. You just create Jim. Initially, the spouse will just be null, default value. Let's not worry about the name attributes because you can pretty much see that from here, right? Just save some space for drawing. The second line over here is Elsa. Elsa is pointing to another object, different objects. The spouse is also null. So we have two persons starting to be single. So they can be married, yes. Let's now talk about this interesting line over here. Okay, this line over here. And what you have to really be very clear is about which one is the context object, in this case, Jim. Once we know what a context object is, we're going to replace every occurrence of this in the code by Jim. And then we know that the argument is actually Elsa. So we're going to replace every occurrence of other by Elsa. And then other here. And also other here. And also other here, right? This will be how things should be instantiated in this example line, right? Now, if you try to trace it, it'll be easy. Let's take a look. What about this line? Jim.spouse not equal to null. Jim.spouse not equal to null. False, right? Because it is null. So this part over here is going to be false. Second one, Elsa.spouse not equal to null. Elsa.spouse is actually null, so that's false, right? And we know pretty well about a logical operator, false or false will be false. So we don't really have any error, so we don't execute that part. So we're going to go here for the else part, and then we're going to do the assignments, right? That's something you know pretty well from before. The first one, Jim.spouse equals Elsa. Jim.spouse, rather than pointing to here, is going to point to wherever Elsa is pointing to. And the next one, Elsa.spouse equals Jim. Elsa.spouse, rather than pointing to null, is going to point to wherever Jim is pointing to. And that one is going to do the necessary updates. All right? It's a very small example, but I think it got many good details for you to understand. Make sure you study that properly. Yes, question?
Let's just say we didn't put either or this dot spouse equals or other dot spouse equals this. What would happen? So like you wouldn't put one of the two.
Sorry, can you, if I understood you correctly, you're saying for the else part, you don't put anything.
Not like only people like one of the
Oh, I see what you mean. Good question. The question was, what if I don't have, let's say hypothetically, I didn't have this line, let's say. That's a good question, okay? I think it might be good for me to talk about this explicitly. Oops, sorry. There we go. Okay. So let's say this. We say this, the spouse, equals other. Also, other the spouse equals this. I'll talk about it in just a moment. And then we got Jim here, and person, and spouse, right? No. And then we have Elsa over here, which is also person. Person, and then spouse, right? Just a sketch, all right? Also no. Your question was, what if we didn't have this line, let's say? Okay, good question. What's going to happen here is, and remember, Jim is this is going to be replaced by Jim. Other is going to be replaced by Elsa, right? So what we will do is, we're going to only do this variable assignments. Jim.spouse is assigned to Elsa. Jim.spouse, rather than pointing to null, pointing to wherever Elsa is pointing to. So what we're having is the following. If after this, let's say we try to check the following Boolean condition. We say Jim.spouse equals Elsa. Also, Elsa.spouse equals Jim, right? In the what the expected behavior should be, both should be true. What about now? With that wrong implementation. Is the first one true? Is that true? According to diagram, it's true, right? Good. What about the second one? False. Apparently, it's too bad, right? When you do the marriage, it's only one way, but not both ways. That's why both lines are important. Does that answer your question? I hope, right? Of course, you can think about symmetrically, what if I don't have this line, but I only have this line? How are these two going to change? That's something for you to think about. All right? Good. Yeah, for this marriage kind of exercise over here, I think the essence of that is whenever you do some updates, sometimes it might have to be bidirectional. You want to do both ways. That's something you will have to do in lab 2, I believe. Okay, so I think it's good to learn this. Guys, any more question about this exercise? It's now time to ask. All right, I hope everything is clear. At least you got 60%, 50% about what's supposed to be learned. All right, watch the recording if you want to, or just ask me during the office hour. This is important, all right? Cannot emphasize enough. All right, so that's the first topic. And the second one would be, I want to briefly mention about helper method. Right, this is exactly just, this might be something interesting to see very briefly. This is something you can also take a look, okay, about the dot notation. I'll show you some example here, okay? Let's say over here. Let's say the marriage has been done correctly. So now if you see Jim, the spouse, is definitely referring to Elsa. And also Elsa, the spouse, is definitely referring to Jim, right? I'm going to write the following expression using the dot notation. You tell me what the value is. I'm going to write, how about here? Okay. What is that? First of all, is it valid? Well, first of all, take my words. It's valid. You can write it in Java. Okay? But let's say it's valid. What is that? By the way, I don't know the answer just yet. I need to trace it. Right? I just came up with it on the fly. Jim? Okay. I trust you guys, but let's verify. Okay? Did you have a question or? Okay, good. This is how you do it. I think this might be something you might see similar in the written test 1. You might see that. Maybe that's a hint for you. Let's take a look. Once you got a diagram, everything is easy. Start with Jim, dot spouse, dot spouse, dot spouse, dot spouse, dot name, Jim. Basically, every time you see that spouse, you have to go from the current objects to the other objects. You will just have to see how many back and forth you will have to go, and then the final answer. I'll do one more time, right? Just in case you're going to get lost. Jim, that spouse, is going to refer to here, right? To start with. That spouse over here, that spouse over here, that spouse over here. So this object here has the name Jim. All right? So the final answer here should be Jim. All right, so that's basically what that slide is actually talking about. But you can still go over that. Just make sure you understand everything. Okay, helper method. I just want to go over this slide together with you here. So the helper method is actually some topic that's not really about how correct your code is. It's really about how maintainable your code is. To make this long story short, whenever you see that your code actually got duplicates, if you actually got the same block of code appearing more than one time in your projects, that's really a good sign that you should have some helper method. That's a general principle you can remember. Right? I can tell you that even for many of your colleagues who graduate from the degree, they still write code, which we call the code smells, meaning that they got many duplicates in the code. That's something you want to minimize as much as possible. Okay? And yeah, that's what people usually say. Your code smells. All right? And then how do you really eliminate the smell in your code. You want to somehow factor out the duplicates into a single method. And whenever you want to use that block of code, just call that method. That's the principle, all right? All right, that's the principle I want to mention to you. If you're really interested in spending some time, walking through every detail of that example, you can also look at this link. Actually, that's a lecture I gave before. It got very good quality recording. You can also look at that. But I would say at least you should know how the helper method should work. I gave you 3 different flavors about using the helper methods, right? It's good for your learning. Any question? And by the way, you should now be very familiar with this particular programming pattern, right? That's from your Lab 0 Part 2. If you have no idea what I'm talking about here, you're already behind. You want to catch up, right? All right, so that's about helper method. And then we're going to move on to the final topic for the review. All right, let's see. Okay, static variables. Can I just ask, how many of you who didn't learn about static variables back in the first year? Everyone have seen that, right, somehow, I guess. Oh, you haven't? Okay, sure, no problem. Yeah, but if you have seen that, it's a good review, maybe a new application for you. If you haven't, now is the time to learn it, all right? Right, let's take a look. The example I would like to use for static variables is a very practical one that might be something you can use for your lab or maybe programming test later. But let's take a look. Okay, so here's a problem. Okay, I'll go over it with you. Let's say, let's see. Okay, this might be better. The problem we want to solve over here is object addresses is actually very hard for human to read. So we don't necessarily want the object addresses to be maintained. Well, it's actually there, but we don't want to use them for us as a programmer. What we want to use like a ID, like a student number or employee number. But employee number or student number must be unique for every student or every employee. That's something we'd like to maintain. Okay? Our first sketch of the solution, let's say we don't know anything about static variable, goes like this. We have the account class. Every account has an attribute called ID. That's kind of the unique ID we want to have. All right? And then we have the string owner, like the owner of the account, Jim, Jonathan, and etc. And then we may just want to get an ID of that particular account, right? And then we got the account constructor over here. And every time we want to create an account object, and you can pass an ID, and also you can pass the owner name. So ID over here is some unique ID you have to pass as arguments every time. It's manual, not automatic. Okay, set the ID, set the owner, right? Hey guys, hey, at the back, could you please? Yeah, thank you. All right, so we got account tester over here. So let's say we got account number 1, account number 2. And notice that what I'm doing here is we got some unique ID that's being passed as arguments, right? So here, this will be some manual management of the IDs. When I say manual, I meant every time you want to create a new account objects, you have to pass that particular value. You want to make sure what numbers have I used so far. Maybe I have used a number up to 10. That means I got to use 11, right? That's what I meant by manual. And what you want to make sure is you want to make sure every account, they have the ID different. That's really what we want to achieve. I can tell you that this particular implementation for now, without using any static, is correct. Nothing wrong with it. But it's very error prone because you have to manually manage the IDs to make sure every time you pass some ID, that's unique. Sometimes, let's say you forget, you pass an ID that has already been used by somebody else. That's going to be disaster for your database, for example, right? So we want a way that's going to let Java itself manage the ID uniquely for us. And the solution will be static. Okay? Yeah, typically when I introduce this topic, maybe in the first year, I'll let people try to sketch a little bit about their solution. But to save time, why don't we just go directly to the ultimate solution? But before that, I want to do one more thing for you, just to review what static variable really, how they really work, to be distinguished from the normal non-static variable. Okay? And I want to show this to you. So I got this fragment of code. I'm going to go over with you, but I would encourage you. I'm going to already post it on the eClass site. Sorry, not eClass, the lecture site. So there is a project there called a review lecture classes and objects. If you expand it, there is one package under which it's called static variables. That's the code I'm showing you now. I would encourage you to play with it, make some modification, and see how they work. Right? That's something I can leave to you. But for now, I'm going to focus on explaining that very quickly. Okay? And you also need to know how to trace static variables. Okay? So we have, let's say, one class called counter. All right? And we have two variables or attributes over here. And notice the difference over here. One has the static. The other one only got private, does not have static. Agree? Okay? Syntactically, you should know the following difference. For the one that has no static over here, we call it a non-static variable. I'll write it down. That's called a non-static. Non-static simply means every object of type counter has their own copy. Okay? So each counter object has its own copy. That's really important to remember. That's something we kind of assume up to now. But now, since we got static in the context, we have to distinguish, right? Each account object has its own copy, right? That's about non-static. The next one, you can see here, I'll try to maybe highlight in different color. How about this one here? This one here, okay? You can see we're using the static keyword, so that's called a static variable. And now let's understand what they really mean. So this one over here is called a static variable, or you can say static attribute, that's okay. And this one here is kind of the opposite. Rather than each object of type counter has its own copy. Now, for static variable, all the counter objects will share the same copy. Right? You can see very different, right? The opposite extreme. All counter objects share the same copy. Let me get to some context right away. You might be having this question, why should I get some attribute to be non-static, some attribute to be static? So here's the principle. Whenever you want to have a global variable that's to be shared and modified by all the objects of a particular class, they should be static. That's the principle. Otherwise, if there's no such global thing you want to modify to be shared, everything should be non-static. Right? You might be wondering, oh, what about static method? I would say don't worry about it for now. Let's make it simple. Just static variable. All right? All right. Having this in mind, I'm going to visualize what's going to happen later, but let's now take a look. We got a counter. Oh, one more thing to say. Typically, you will not want to put any initialization over here for the non-static attributes. You want to initialize non-static attribute only in the constructor, like what we did so far. But this part over here is some typical initialization for the static attributes you want to do, right? That's a difference. It's not terribly wrong if you also try to initialize the non-static attribute over here. I know many programmers do that, but I would say it's not ideal because it's somehow you're kind of making the initialization context a little bit mixed up. It should be only in the constructor for the non-static. Anyway, okay. All right, so we got a constructor here that's initializing only the non-static, right? Let me just say one more thing here. You can see over here, the static attributes is not initialized over here. Right? You can see the static attribute G is initialized right here, not in the constructor. All right? All right, so we got two methods over here. We got get local, just return this.l, the non-static one. And then we can increment the local, which means we simply increment the L. And we can also increment the global, we'll say G++. You can say this.g++ as well. All right? That's about the class so far. I think as far as this class is concerned, we have two different variables, non-static versus static. Right? So far, so good. just about definition. In the other class on the right-hand side, we're going to see how we can use these two variables and try to trace the program. Once you understand how this simple example works, you will actually appreciate how we can use this for automatic management for the ID. All right, let's try it. Let's say we got two counter objects over here, right? C1 and C2. Let me try to visualize it. So we got, let's say, C1 and C2, right? So we got C1 over here, and then we're going to visualize it. Let me just say C for counter. And how many rows should we put over here? So the principle would be you only put non-static attributes in the visualization in the object because each object has its own copy, right? You don't really put a shared copy like a G in each object. You don't do that. It'll be too difficult to trace. So what I would do is I'm going to put L here, only L. So what I will do is I'm going to put L over here, and initially it's simply just going to be 0. All right, that's C1. And also we got C2. And then, similar, we got C here, the counter, L. You can see right away we are doing exactly what we said for the first point. Each object has its own local copy of the L. What about the second point? How do we visualize it? I would say the way to visualize is really up to your personal preference. As long as you set aside some copy of that particular variable, that'll be okay. So this is how I would do it. What I would do is I'm going to put also like a box. And this one here is going to be just counter, right? And then I'm going to put also, this will be the global. But this one here is not really an object. Think about it's some separate copy that's shared. So I might just put a star over here. That means this is a global copy to be shared by all the counter objects. Right? I can put a star just to tell me that it's not just an object. It's not. All right? And it's initialized to be 0. You can think about this will be the consequence of these two lines. We got C1 and C2, and also we set aside some global copy, G. All right? Let's now try to see how we can manipulate these three values. We got two copies of L. We got one copy of G. All right? All right, so now let's try. We say C1.getLocal, right? That one's going to get C1.L, right? You can see the context object here is C1, also versus C2. So this over here could be C1, could be C2, right? This one's easy. They will just be 0. And then, how do we use static variables over here? So these are all the possible ways you can do it, okay? You can either say C1.G. That one there is going to refer to the shared copy, which is 0. If you say C2.G, it's also referring to this shared copy, the same copy. However, if you try C1.G and C2.G, Eclipse is going to give you a warning. Okay? C1.G and C2.G. There will be some warning. Not really error, but it's just a warning. The static variable, which is global, should not be specific to an counter objects, right? That's a warning, okay? So this is how you should write static variable. You're simply just going to put a class name. So counter over here is the class name, and the G over here is the static variable. You're saying that I want to get a shared copy of the counter class, which is G. That's basically what we're saying. All right, just remember, if you can say C1.G, C2.G, but there are warnings. I would suggest try to avoid them. That might show some conceptual misunderstanding. Always do, for static, say counter the class name and also G. So what does this mean? That means in order for you to really get a value of a static global variable, you do not need to create a context object for that. Okay? I'll write it down. This will be very important for you to remember. Not necessary to create a context object for this particular usage. All right? And for global value, you can see it's going to be just 0 as well, right? Because the value here is 0. What I would do, let me just put it down. 0, 0, and also 0. Let's now take a look at what's going to happen if we do this, right? These. When we say C1.increment local, we're calling this one here. So that means we're going to replace this over here by C1, right? So C1.L plus plus, we're going to change just C1.L, right? Just that copy. When we try, let's say, how about this? This is C1.increment local. What about C2.increment local? We are still calling this method here, but now this will be replaced by C2. C2.L plus plus. That means we're modifying this copy here, right, to 1, right? And then what about C1.increment local, C2.increment local? That one there is going to be something like this. C1.increment local, global, is going to call this method here that will increment G by 1. We are modifying this copy over here. As soon as we have done this, if you try C1.get global, it's going to get 1. If you try C2.get global, also it's going to get 1, right? Because it's shared copy, right? Finally, if you try this one more time, let's say this. If you try this one here, C2.increment global, the same method here, and then you're going to increment the same global copy here from 1 to 2, all right? And so in the source code I made available to you, I actually got print statement after each intermediate changes to make sure you understand what the value have been changed. That's something I would suggest you actually try and convince yourself. All right? Finally, rather than just using some methods to change the static variable, you can also try this as well. Right? You can see counter class, the global variable, G, static one, is assigned to itself plus 1. And this one over here is just going to be, let me see, how about this? And for this one over here, we're just modifying this global copy from 2 to 3. That's another change, right? Right, so it's a very simple example, just summarizing how you should distinguish between static versus non-static. And we're going to use this idea to actually manage our ID automatically. Any question? Yes? Static is a global variable, not really global objects. It could be a global object, but that'll be too complicated for now. I would say for now, you can assume every time you need a static construct, it will only be like an integer, like a counter. That'll be enough for now. Yeah, global thing is a global item. Good. All right, any more questions about this? Yes? Sorry, say that again? How do we know? You can see, how do we know it's a static variable? If I understood you correctly, you can see here, when we declare that variable, you can see static over here, right? L. Okay, L here, you can see it's not static because you can see there's no static here. That's why it's non-static. If you don't see static, that means it's not static. If you see static, it is static. Well, it sounds very dumb, but that's the truth, right? Okay, that one is to say, when you have the normal non-static attributes, you only do the initialization of the attribute value in the constructor. But for the static variables, usually because you don't necessarily have to create a context objects, right? You just use class name dot static variable. So that's why you will normally just initialize it right away in the same line. That's the common practice. Okay? Make sense? Maybe? You mean the orange one or the green one? This one?
Yeah.
Okay. Static attribute not initialized here. That is to say, in this constructor over here, we didn't say anything like a G is initialized to 0. That's not the right place to initialize it. You should do it right away in one line. Make sense? Good. Question?
So that means that if you did initialize G in the constructor every
Let's say.
time you need a new object, it would change the value.
Yes, that's correct. That's a good question here. Yes. So, your name? Marcus? Okay. What Marcus just said is a very good thing for you guys to try. I'll put it down for you guys to try. Thanks to Marcus, I got more inspiration for your written test, right? No, but you guys got to learn. I think that these are important stuff. All right, good. Let's say this. Let's say the same setup over here, but what I will do is I'm going to put over here another line. Doesn't matter before or after. I would say the static variable g, let's say plus plus. Make it a little bit interesting. Whatever its current value is, plus 1. Okay? What does this mean? Okay, I will sketch a little bit the idea with you. This means you're going to increment the value for g every time you're trying to create a new counter object. However, if you never create a new object of counter, you only try to use counter.g, you may never change its value. So what do I mean? I'll sketch for you. But you should really put it down in Java code and then try to play with it. Let's say this. So here we got initialized to be 0, so the counter value will be 0 anyway to begin with. Right? It's a global one. It's actually 0. All right? And then we actually got, let's say here, let me write some code over here. If I say counter C1, new counter. Let me do another one. Counter C2 would be new counter. Okay? And in between, what I will do is I'll try to print something. System and outer print line. I will say counter class dot g. And if I may just save some writing. One here. One here. All right? That'll be some example. I will show you. You can feel free to modify it. All right? Now, green one is going to be printed out. What will be the first one? 0. Thank you. I'll put it down. And what will be the consequence of executing this line over here? That one there, of course, is going to create C1, right? It's going to create this object over here. But when we execute this line as part of creating C1, it's going to increment this value to 1. That means when we actually get to this line over here, it's going to be 1, right? Because it has been modified from 0 to 1. Let's try to create C2. When we execute this line here, C2 is going to be created somewhere. And then along the line that we're creating it, we're also going to increment G further from 1 to 2. So that means when you try to say print lines, counter.g is going to be 2. All right? Hopefully that can strengthen your understanding, just an extra example. Yeah. Yes? You mean the static variable? Yes, only one copy. Okay? Yeah. Yes, that's correct. So in this case, it doesn't matter how many counter objects you might create. You're only bounded by computer memory, so you don't need to worry. You can think about as many as you like. All the objects you ever create from counter class will share just a single copy, just a single one. Mm-hmm. Okay, one thing to say. Good question. One more thing to clarify. This part over here about initializing the G to be 0, this initialization is done only once. Just to initialize that global variable, just once. However, this part over here, what I just put, this part here is going to be executed whenever a new counter object is created. Maybe they kind of answer your question, right? Good. Yeah, one more time. This one here only initialized just once and for all, just once. If you want to do more to the counter, you can do that. If you do that in the constructor, that means every time you create a counter object like these two, they will do something to the global copy, which will be visible to all the objects. All right? Hopefully it's not too complicated, right? Okay. So I think we got about, let me see, about 18 minutes for today. I'm hoping to maybe finish. I do have some example to finish. We'll see. Maybe we got to run until the end, but that's okay. I think static variable is so important. We'll see. Yes, question? Yeah, okay, the question goes like this, right? So I'm glad you brought it up. Maybe, what I put here, for example, here before, I say G++, right? Okay, good question. If you try this dot G++, all right, it's not an error. It would be just a warning. Because remember, in order to access the static variable, you just need a class name. But when you put this, that means you need some context objects, which is not necessary. So that's why it's going to be a warning. Okay. Yeah. Good. All right. Let me now talk about three things. Number one, we're going to see how we can use a static variable to actually implement a solution for the automatic management. And then we're going to see two possible errors you can make on the static. And maybe that will just last us until the end of the class, which is okay. Okay? And then I'll start the exception topic maybe on Monday. All right? But I got to finish this. All right, so let me now, right, that's about the motivation over here. That's about the manual management. Static variable. Okay, I'm going to go over the solution with you. Give me a moment. Okay, here. All right, so this will be the correct solution. You can see automatic, right? Having the knowledge about the distinction between static versus non-static, let's see how they work. What we have under the account class is we got some global counter. I made the name very explicit for you. Initialized to be 1. Static, right? We got a non-static variable, just ID. We got a non-static variable, just owner, okay? And then we got account constructor over here. And here, I'm also trying to modify the global counter, which Marcus actually suggested before. So this is indeed possible. That means every time we try to create a new account object, we will actually modify the global counter somehow. That's what we will do, all right? And then we're going to use this part of the code to test it, all right? I want you guys to spend just 1 minute, please. Look at this class only, just this one here. I want you to pay as much attention as you can to see how things are being implemented. You may have some doubts, but when I trace the code, everything will just work. Look at that for 1 minute, all right? Just the account class. Okay, another 30 seconds, and then we should really trace the code together. Things will just work somehow magically. Okay, just one more moment, and then we'll start tracing it, all right? All right. Okay, let me give you a little bit connection here. You can think about this part over here, that's static, correspond to how we had to do manually before, like a 1 and then 2 and then 3. But now it's going to be a static variable that's stored internally, which will be managed automatically for us. Let's see how. Okay, let's now trace the code. When we first create ACC1, right, let's do that. ACC1 is, let me put it here, ACC1 is pointing to some account objects. And remember we said in order to visualize it, you have to only include non-static attributes, right? In this case, it would be ID and also owner. So that will be account, I would say ACC. So we got ID and also we got owner. All right, in this case, the ID would just be, okay, before that, remember global counter here, I will set it aside. The global counter here, I'll just say GC, just for short. Initialize only once to be 1. So let me set it aside over here. For the account class, we have a global variable. I'll put a star here. It's not really an object, just set aside, right? That's called GC, global counter. Initialize to be 1, all right? And now, when we create ACC1 objects over here, we say that ACC1.id will be the value of the global counter, which is 1. And then we say global counter plus plus. What would that do? That one is going to increment this from 1 to 2 for the next account objects. That's going to be created at some point later. And then we're going to say this.owner will be owner. So this will be ACC1, right? So the owner is going to be just Jim. Any question about the first account creation, the first one? Pretty straightforward, right? Let's do the second one. Just make sure you're 100% okay. ACC2, so we're going to say ACC2. And then we're going to put account over here. And then we got ID, also we got owner. And don't forget, at this point, we already got the global variable here already set to 2. Don't forget, right, from the previous updates. And let's execute line by line. So this is now going to be replaced by ACC2. ACC2.id should be set to the current value for the global counter, which is 2, right? It's 2. Notice that we got 1 versus 2. And when we created the account objects, we didn't have to pass 1 and 2 over here. We don't have to. That's why it's a better solution. So we got 2 here, and then global counter plus plus. That one there is actually going to increment the global counter over here by another 1. So number 3 would be the ID for the next objects, not the current one. All right? And then we say ACC2, the owner will be just Jeremy. Right? So that one is going to be Jeremy. And the final line to really double check. ACC1.getID, ACC2.getID, they are different. They are unique. And now if you create as many objects as you like, it's guaranteed they will have different IDs. All right? That's how we use a static variable. I think as far as the course is concerned, you only need to understand this particular pattern. Of course, this pattern, I can create many variants to test you, but just make sure you understand the thought over here. That'll be the first, that'll be the solution. Any question before I move on? Okay, very good. And let me now talk about 2 possible errors. Okay, that's exactly what I just said, common error. Okay, the first one. Again, I'm going to ask you guys, please take a look at this class over here. Let me set up the context. We have a client class, and we store an array of accounts. Also, we got the number of accounts, right? The counter that we learned from Lab 0 Part 2. And then also we got add account, which is going to add the account to the end of the array according to the counter. That's what we want to do, right? Take a look at the client class. I'm making the assumption you already know about the programming pattern, which you learned for Lab 0 Part 2. If you don't, you're going to catch up. Look at the code over here for the client class for 1 minute. And can anybody tell me if there's anything that's wrong? If you do believe it is wrong, what I would like is some explanation from you why you think it is wrong. Don't just tell me maybe there should be a static, but it's not put non-static, or vice versa. Give me a moment. I'll point you. Yeah, think about it. I think it's really a challenge. Okay? Okay, why don't we start with you? Please, go ahead.
I'm not entirely sure, but isn't that private and static are clashing in the way they work?
You mean, okay, are you referring to this particular line?
Yes.
Okay, why do you think that's wrong?
Well, like as we discussed, static essentially makes it global variable.
Yes, I agree. That's global. Yep.
That lets you access it through any of the objects, but then private does the exact opposite.
not quite. Okay, you're basically talking about would there be any potential conflict between private and static? No. That one is actually okay. But you're getting somewhere that's actually promising. I'll help you guys a little bit. Something wrong with this line. Something wrong. Terribly wrong. So wrong. Do you know where? Well, since we're talking about static, right? So it got to be the static that's wrong, first of all. If you guess that, you guess right. But now we need to understand why putting static over here is terribly wrong. Let me remind you, number one. If you go back to your lab 0 part 2 and also that PDF notes, if you look at like an NOP, number of counter, you know that counter there, we never put static. So now what I put static in front. I was hoping that maybe things will still work. It turns out no. Things will go very, very wrong. Now we need to see why it will go wrong. All right, can I understand what I'm saying so far? Okay. If you compare this part of the code with your lab 0 part 2, the only difference is we're adding static to the counter. Let's now trace the code to see why it is wrong. I would like to see if anybody can actually imagine why this will be wrong. Can I just ask just for one more minute's pause? Okay, I already told you this is wrong. And if you guys can use this particular example to help you, that one can illustrate why it's actually wrong. I'll pause for one more minute. So you guys can think about, picture how you're going to visualize the execution of the code. I agree, this one is slightly more advanced, but I think it's still reasonable. Okay. Yeah, I'll point to Marcus in just a moment. Maybe he got the answer already, but that's okay. Yeah. Okay, Marcus, share with us your thought.
So I think that that's when if you keep the static, so because you're starting at number of accounts is equal to 0.
Yes.
And then you're using that to increment adding the accounts each time. So for the first time when you go client bill equals new client bill, and then if you add an account to like if you add an account there, then it will increment number of accounts to 1.
Yes.
So then if you use a different object, now instead of putting that new account in the index 0, you're going to be putting it in index 1.
That's absolutely brilliant. That's exactly correct. Thank you. All right, but don't stress over too much. If you didn't really get there, that's okay. Let's now do it together, right? I'm going to basically repeat what Marcus just said. I'm going to make it a little bit more elaborate, a little bit more visual. That's what I'm going to do. But Marcus was exactly correct. Okay, let's take a look. What we'll do is we're going to trace line by line. Line number 1, line number 2, right? For the constructor, no trick, all right? Basically, we're going to have Bill and Steve. So Bill is going to be a client object over here. I'm just going to say C for short. And we don't include the number of accounts as part of the object, right? It's global. So what I would do is I'm going to set it aside. And then I'm just going to put the clients over here, but I'm going to say global, right? That's why I put a star. The number of accounts initialized to be 0, only once, right? Set aside. So let's create the first object, Bill. And that one there is going to set apparently just the name, right? So also, let's not worry about the name over here. Let's get it more focused. Let's focus on this particular part, accounts. It's an array, right? I'll say EECS for the accounts array. And let's assume we're just going to initialize it to be certain size. Let me draw a little bit better, if I may. That one there is going to point to the beginning of some array over here. And let's say from 0, 1, all the way to, let's say 30. Doesn't matter. That's a magic number, okay? And then for the second one, Steve, got to be the same. Steve, and then pointing to the client object over here, EECS, and then from 0 all the way to 30, let's say. All right? Up to now, maybe some of you can already see what's wrong. This object here has its own copy of the list of accounts. The list of accounts, yes. This client over here also has its own copy of the array of account. But the problem is, they're sharing the same counter for storing where the object should go. That's the problem. Let's see. Here, if I try bill.addAccount, right? Context object bill, I'm going to call this method here. So that means this will be replaced by bill. This will be replaced by bill over here. What I will do is, so accounts, that will be this bill.account, which will be here. Which index? This will be number of accounts, which will be 0 over here. I should really store that over here. That one there should be assigned to some ACC, right? So this, of course, should really point to some account. Let's not worry about it. The position is more important. And then after this, we're going to increment the global counter by 1. And that means this shared copy is going to be used by another add account. Let's see. Let's try this line over here. ACC, it's this one here, sorry. Point to the wrong place. This one here. If I try Steve.addAccount over here, I'm going to call this method here the second time. But now, the context object will be Steve. So it will be replaced by Steve. And this part will be replaced by Steve over here. And now, you see, in order to do that, this global counter here has now value 1. So you're skipping this guy over here. Right? You're simply saying now index 1 is actually going to actually point to whatever account it is over here. That's wrong because you're wasting space over here. Guys, you see that? Okay. I want you guys to do some optional exercise, which I really recommend you do. Try another 2 lines just to see bill.addAccount. And then maybe ACC3. And then Steve.addAccount. And then ACC4. You can just create another 2 accounts. The exercise will be after these 2 lines over here, what's the object structure going to be like? Are we going to get many skipping slots in the array? If so, how? That will be the exercise for you. All right? This will be the exercise. Over here. All right? I think I can make this a little bit more readable for you. Give me a moment. How about this? This one here and this one here. All right? Any question about this? Of course, I'm assuming that you actually know about the programming pattern. If you didn't know, catch up and then rewatch the recording to see how this is traced. All right? Okay, I think I'm running out of time right now, so I would suggest the following. Okay, for that final common error, I will finish that within 5 to 10 minutes on Monday. So, very important information for you guys. I'm going to announce that also today. Just give me 1 minute, and then I'll be done. For your written test number 1, you will need to study up to and including, let me see, slide 79. You can put down a number, and I'm going to confirm also in the announcement, okay? I think at this final example over there, I'm going to talk about it maybe on Monday, but that one will not be included in your written test 1, just to be fair. But I think we got enough contents there for you to study. Guys, take advantage of the written test 1 to review everything we have covered so far. I think it's a very fair and also thorough review of what you're supposed to know in the first year. And then, starting from next Monday, I'm going to assume everyone is on the same ground, knowing OOP, the basics, so we can cover the more advanced stuff. Marcus, question?
I'm assuming you're going to send us an email about the length and
Yes, I'll give you more information. I can talk about very briefly now. So the written test number 1 is multiple choice based. There might be some fill in the blank you have to type from the keyboard, but everything is going to be done on the E-class. So it's why it's so important, make sure you can log in to the computer and also log into E-class from the WSC, William Small Standard Computer. Multiple choice question, you will be given 30 minutes to do the written test number 1. Okay, I'm going to confirm that. And I don't know the number of questions just yet, but I think I will give you some reasonable number. Okay, and when you come, just log in, and then I think I will give you a few minutes to set up. You can bring sketch paper. That's okay. That's fine. You can bring your pen and pencil. Okay, there will be a strict rule for the written test 1. you cannot launch Eclipse or any programming IDE during the test. It's going to be completely paper-based. Well, of course, you will type your answer from the keyboard. You cannot use Eclipse, meaning that you cannot simply copy and paste some code from the screen and then launch it and run it. No, you're not allowed. All right, I'm going to write all these rules down in the guide, so you can expect to hear from me either by the end of today or by the end of tomorrow. All right? Guys, thank you so much, and I will see you next Monday. All right?